All right, let's get going. Thank you for your time. I think like many speakers, I'm kind of a noob in everything Singapore. First time here. Very impressed so far, so nice, nice to be here. Today we're going to talk about Hibernate. Probably many of you actually use the object relational mapper, the JPA mapping, but there is actually quite a few other projects. So what we're going to do today is really have a discussion of what is new about Hibernate, the object relational mapper, but also give you some of the features that are not necessarily new, but that people tend to not know about, and will, hopefully you get concrete takeaway to use into your projects. And I'll also describe, the various other Hibernate projects, again, to make you be aware that there is just more than the object relational mapper in this one. So my name is Emmanuel Bernard. I work for RedHat. We actually made a pretty nice Singapore custom t-shirt. So go by the booth and get one. Just ask to register to the developer program, which has our products for free, but also quite a bunch of good content. You can know everything about me online. The key thing is I've been part of the Hibernate team for a long time now. I've been founding some of the projects we're going to discuss. And also I worked heavily on the JPA implementation when we started to work on the specification. So with no further ado, let's go and start discussing Hibernate ORM 5. So who uses the latest version, Hibernate 5 or more? Okay, my boss is here. I'll say, hey, yes, I do. So I guess that's going to be a very interesting presentation for you. Who is using 4? Okay, 3? Okay, quite a few. And 3 is, I don't know, guys, like 10 years old or something, so get on it. So the first thing we worked on is rethink how we bootstrap. So for the Hibernate 3 and Hibernate 4 people, you remember that you have your configuration object that is basically a melting pot of everything you can do. You can add properties, you can add classes, you can create the initial mapping information and add classes again. And that was pretty much of a mess for us because the life cycle of things was not very well defined. It wasn't really defined at all, and we always had to do several phases of re-looking at the, what we had looked before to make sure we haven't forgotten things. So that was one part of the rethinking. The other rethinking is that in a more and more modular universe, so you probably have heard that Java 9 is going to come with the Jigsaw project, so the modular system. But even way before that was OSGI, which is coming, which is all modularity rules. And app servers like Wildfly also use modularity at their core to simplify the deployment and had quite a few interesting things like the ability to deploy 2 different parallel versions of a given module or libraries without breaking everything. As long as the same library is not used within the same active module, the other sub-module can work with different versions of their library without breaking things. Who ever had a problem where 2 versions of Jackson were conflicting and you had to pick and choose the 2 libraries and there was a bit of a mess? That's trying to fix that kind of problem. The other advantage is security, because we only expose what is needed inside a module, then there is less stuff exposed. There's been a famous CVE in the Java universe around Java collections that were allowing the deserialization of pieces of code that could be arbitrarily executed. So that one would have been kind of hidden by the security as long as you didn't have the command collection in your direct application, even though any of your dependency would have used it. And finally, you can actually speed things up. So Wildfly, that's one of the good reasons why we did that. You can parallelize the load of the various classes and really be super efficient. So with all those good stuff being said, it was pretty much a nightmare for us to actually modularize, make sure Hibernate works in a modularized environment. And OSGI before, and then Wildfly, and those guys were like, Hibernate, you you're really screwing things up. We really need a better way to integrate with you. And the problem is Hibernate uses a lot of different resources. There is Hibernate, the code base, right? That's one thing. And then Hibernate has various extensions, and we use service loader, the meta-inf / the service name, the file inside that to really detect a new entity. And so we need to pick up and look at other modules or other jars to see if they are available. We look at your entity because we need to persist those, so we need to access those. We extend your entities because we create proxies, so it's essentially a subclass of that. So we need special access to that. We have your XML file that are here and there. So that created different resources that in a modular system are in different areas. So we really need to give the hooks for the various systems to really get access to that. So it took us years, literally, of work. We think we finally got it properly covered. And the way we did that, it's a little bit small. I don't know if I can. Yeah, not really. Is by separating the bootstrap into different well-defined steps. The first one is to define the services we have access to. A service is like the data source or the connection pool or the second level cache or the class loader that we're using to load your class and so on and so on. So that's the first step where we get all the tools we need. The second one is let's list all of the entities or the mappings that the user is going to use. So it could be the list of classes, could be your hbm.xml file, it could be your object orm.xml file if you use JPA. And we've got the services, we've got the metadata, and then we bundle them together and we bootstrap the session factory. That's how it works nowadays. Who is using JPA as the primary API instead of Hibernate as the primary API? Okay. So for you, either say in Java EE, the app server actually bootstrap that for you, so you don't really care about that. Or even if you bootstrap JPA directly, you don't really care because you do persistence.create entity manager factory, and all of those steps are actually done inside Hibernate. Another thing we did is look at Java 8 and look at what features made sense for Java 8 that we didn't cover inside Hibernate. So the main ones were the support for the new date and time types. And since we decided to make the move, so I think it's in Hibernate 5.1 where Java 8 and more, right? So starting with Hibernate ORM 5.1, you have to have Java 8. We also look at our older APIs and try to add generics and blocks and stuff like that here and there to just make the feature incrementally better. If you use date and time, so for Hibernate 5.1 and above, you don't have to add this additional Maven dependency. But if you use 5.0, since it's pre-Java 8, we had to add a separate module for the date and time support. But bottom line is, if you use local date, local time, offset time, no, they are supported, and by default we use the most interesting type for the support. So it's a nice addition. Generics and auto-closable. So again, if you use an app server or Spring, they will actually start and stop the session for you. But we made our resources like sessions, session factories, scrollables, actually auto-closable. So you can use the try resource block that Java, I guess 7 brought to the table. The other stuff you can see if you're familiar with the native session. I'm sorry, it's super small. Don't know why. Anyway, I can cheat. Hold on. There you go. If you're familiar with the session API, you can see that session.get address. You don't have to downcast address to the address type. So that's the genericification that I was talking about, which is present in JPA but wasn't present in the Hibernate APIs. Generally speaking, we try to deprecate our old APIs that were similar to the JPA APIs just to focus on the addition. Okay, one big feature that is not out of the box, but it's quite interesting is bytecode instrumentation. So out of the box, Hibernate, to do the lazy loading boundaries, uses proxy. So when you load an object which has an association to another object which is lazy, what we give you is a proxy. And when you reach that proxy and you actually try to access one of the getters, that's when we will actually go to the database, load the data, put it in, okay? So that's proxy. It doesn't require bytecode instrumentation or any magic like that. But if you want, you can enable bytecode instrumentation, and there's quite a few interesting benefits. So to take a bit of a step back, let's see how Hibernate knows that you changed your object. So you load an object from the database. Hibernate loads literally the result set. So it's an array of columns, okay? Out of this array of columns, we create a new object, we populate it, and we give that object to your application, okay? That's the manage object in the session. But we keep this array of columns somewhere in the session as well. You play with your object, you change some stuff, and so on. And when you do a flush, or when you do a commit, which will trigger a flush, what happens is for all of the managed objects in our sessions, we look at them, and we compare the value of the various properties to the array of columns that we have here, and we say, is it different? Yes. Is it different? No. And if one of them is different, then that's when we trigger an update. Otherwise, we say, oh, the object hasn't changed, so we don't have to do anything. And it looks like it could be expensive, because for every object in the session, you really have to do this check for every property of this object. In practice, it's pretty efficient. Except in some areas where people have like massive objects or loads of different objects in the session. But with bytecode instrumentation, we can do better, because what's happening is we actually changing the code of your entity itself. And when you do a change, we will know about it in the entity class, and we put a flag on saying, hey, this user has touched this entity and made a change. And even more than that, we know about the changes you've made, and we collect them. So when the session does a flush, instead of going to every single object and do a comparison, it will just look at this flag and say, oh, flag is on, here is the list of changes, my job is much faster, I've got less entity to look, and also I already know the changes, so I can go straight. That's the improvements we've been doing. How do I enable that? If you're in Java EE, actually the class instrumentation is done for you as part of the boot process. Just make sure you enable the use class and answer, and then you decide which feature of bytecode enhancement you want to use. So dirty tracking is what I've been describing about this flag. There is also the lazy initialization of properties that I will mention in a minute, and then the enable association management, which I will mention in 2 minutes. Okay, so let's go on. So that's in Java EE, that's how you do it. You add the properties in your persistence.xml or your hibernate.cfg.xml. But you can do it at real time if you are in a Java SE environment, for example. So if you use Maven, that's the plugin and how you set that up. And again, you can select which features you want to enable. And if you use Gradle, it's pretty much the same. So you add the dependency, and then you enable the module, and you select which property you want to enable. Okay, lazy property. So you've got lazy associations, right? Which means when I've got an object and has a link to another object, I can make it lazy so that I will only load the other object when I actually access it. You can do the same for the, I guess, primitive properties like, street or, like a string or a number or anything. It's not on by default, so you need to use the @basic and fetch type equals lazy. And by using bytecode enhancement, what's happening is that when we load the customer object, we only load the non-lazy properties, populate that, and we've got the bytecode enhancement magic doing things and intercepting your call to the getter. And if the getter of that, for example, the accounts payable reference ID is not loaded, we will go and load it. And until then, what happened is that we treated the properties in 2 big bags. The first bag is we load them right away when we load the object, and the second bag is we load all of the other properties that are marked as lazy in a second step. But it was really a 2-step process, not a flexible approach. So what we've added in the latest 5 release is the notion of lazy group. So here you see that the image is in the group lobs. probably a bad name, but it could have been a name like resources or assets or something like that. And what's happening is that when as a user I do customer.image, then the bytecode enhancement knows about that and will go load the blob and all of the properties that are marked as lazy group blobs in this case. Okay, so you can really have different groups, not two big bags, but the eager bag and then several lazy bags of properties. So it gives you more flexibility. Instead of having to write the flight weight pattern or things like that, you can use this approach. The other one is a small but interesting one. So in Hibernate, if you have a bidirectional relationship, what you have to do is, well, first of all, there is one side that is the owner of the association, which means Hibernate will look at this side to know if you've changed the association and which ID to put in the foreign key column, okay? But from an object point of view, what you should do is update both sides. When you add a link from, in this case, from order to the line items, you also have to link line item back to order, right? And usually people add order.add line item method to it to actually do that kind of work. That's a manual step. If you forget, or I mean, it's always been a bit annoying. So very tiny, small improvement that we did for the bytecode enhancement, if you enable it, is to do that work for you. So in this case, remember, look at that. There is 4 lines in the first block, and here there is only 3 lines, but it's doing the same job. The 4th line is essentially added as bytecode enhancement for you. A tiny but an interesting small add-on. Second level cache. We did quite a few things around that. The first thing is, it's not a new feature per se, but we've been working a lot around improving the performance of Hibernate, but not in a synthetic lab, but in kind of real life. So we took a real life project, we make it run as fast as we can. That means improving some part of Wildfly. That means also improving some part of Hibernate. And because in this example, the project was a very heavy and database intensive application, we really hit Hibernate pretty hard. So what we found at some point is that one of the critical paths was creating so many temporary objects that the VM was essentially at its cap of number of parallel objects it could create. So we reduced the number of objects created by changing slightly the API of the second level cache access to really speed that up. So if you just by upgrading Hibernate, you actually might go one step further on your applications just by benefiting from those performance improvements. Another one which does require an explicit call on your part is what we call cache by reference. Remember what I told you about the flush? We load the data from the database, we keep an array of the column values in the session, and then we create an object, populate it, and give it to you. When we load data from the second level cache, we do exactly the same thing. We load the data from the second level cache, which is this array of columns, and then we create a new object, populate it, and give it to you. Okay? So the second level cache and the database essentially have the same kind of information. Now the negative part of that is that for every session, you create a new object that represents this logical entity. So a country, so Singapore and France and whatnot. Every session that loads Singapore and France would have 2 different instances for each. So in an environment where those objects are like super massively commonly used and created for each session, that means a lot of object creations for nothing. The reason we do that is if those objects are mutable, if you do a change to the country France, for example, by changing, say, the president from the old one to the new one, in a given session, and the object is actually shared across all sessions, then you've got a problem because what is happening in a given transaction is actually leaking into other transactions. So that's not what you want, and that's why we create a new object every single time. But in many key situations, the object that you're caching is actually immutable. That's a country, and you don't put the president's name inside the country object. You put it somewhere else, for example. And here if your object is immutable, then we could actually share the same object instance across all of the sessions that you have in your system. So one object creation and sharing the object across all of the sessions. So to do that, you enable Hibernate cache, use underscore reference underscore entries to true, and then you make sure your entity is marked as immutable, and you make it cacheable, and off you go. Be careful, it also means that this object shouldn't have associations to mutable object, otherwise the mutable object might change, and that reference to the mutable object should be specific on a per session basis. So that optimization will only work if your immutable object has no reference to a mutable object. Various few things. We did a massive amount of work around documentation. So, and I was talking with a gentleman here that said, oh, we moved to some to Hibernate for a while, but we're coming back to Hibernate, so a little bit of infidelity here. But the good thing is that in the meantime, we've reworked the documentation, and it's awesome and very readable nowadays. So go and read the documentation from A to Z, and it will be much more understandable and better. And also, we have been really focusing on the community and interacting with you guys. So we do a blog, and every week, like a bit of a newsletter that gives you tips and tricks and what are the kind of problem people are hitting and how to fix them. So, have a look at the blog. It's called in.relation.to. 2 as in T-O. And just randomly, one of the additional features that we did recently is the way to set the batch size on a per session basis. So batch size is very important because instead of doing, say, one update and going back and forth to the database, we can batch for the same table updates, like as in this case batches of 10, and just do way less interaction with the database. That up until very recently has been a session factory level settings. But what happens is that some use case in your application is very batch oriented, and some other use cases are very just OLTP oriented. For the OLTP oriented, you don't really need those batch size to be too high, because that's an extra work to do on the Hibernate side. But for the batch size, then that's where you want the big batch size to actually happen, because you don't necessarily want speed on a latency basis, you want speed on a throughput basis. So now with the ability to override the settings on a per session basis, you can really optimize those two areas. And by the way, when you when you use the JPA API, how do I access the Hibernate API? So you just do entity manager.unwrap, and then you've got the session object, and from there you just enjoy yourself, I guess. Got access to all of the settings and annotations and APIs and so on. We will come back to Hibernate ORM at the end of the talk, but let's do a bit of a discretion and think about other Hibernate projects. So we've been talking about Hibernate ORM, so who uses Hibernate Search? Okay, well, we need more people in this room, so let me try and convince you guys to. Did you know about it, by the way? Okay, not enough. So that's why I'm here, that's good. So Hibernate Search, where Hibernate ORM is an object relational mapper, Hibernate Search is an object index mapper. And by index, we mean inverted index in the Apache Lucene sense, okay? So what we do is we take an object, or literally an object graph, and we convert that structure into, in the case of Lucene, a document which fills and do the right conversions and so on for you, and then we update the Lucene index, okay? Why do we do that? Is there a mismatch? The mismatch is that an object has many types. There is strings, there is numbers, there is dates, there is nested objects, and so on, whereas in the Lucene universe, there are strings and numbers, pretty much. So you really need some kind of property mapping. The other thing is that an object has an association to another object. In the Lucene universe, you need to denormalize everything. So if you've got an address which has a country and you want to search by the country property, you need to denormalize and inside the Lucene index to have an address.country. So we do that work for you as well. The third thing that we do is really we work at the object level, which means you can write object-level queries and not document-level queries. So it's a little bit of a less of a mismatch. And we do other things like clustering and doing the right batching, and essentially all of the actual indexing is done transparently for you. You focus on the queries you want to write. And the final thing that is pretty much a biggie is that every time Hibernate ORM updates an object, we know about it. Hibernate Search knows about it through an event being sent to the library. So which means every time you do an update via Hibernate, the object relational mapper, we can know about it and we can upgrade the Lucene index for you. So the database and the Lucene index are kept in sync with one another. So you don't have to maintain your secondary index by yourself when you do an update. It's all done transparently for you. Even if you update it and then you do a flush and there is the whole object graph that has changed, all of that is done for you transparently. So yeah, extremely useful, very practical, extremely useful way to get done. So what did we do new about this, this library recently? Well, we always upgrade to the latest version of Lucene. Lucene tends to break APIs quite often, so when you use Hibernate Search, you're pretty much isolated from this API breakage. That's another small benefit. The good thing about Lucene is every time they upgrade, it's faster. So you get the benefit when we upgrade. The other thing is we try to optimize stuff on our side as well. The recent optimization we've done, for people that are really familiar with Lucene, you know about NRT, which is near real time, which is a way to keep your index up to date and be able to query in real time. The small drawback is that it has to be in memory and it cannot be clustered. That's a bit of a problem. So we sort of reused a bit of their strategy, and what we do is for every transaction Hibernate transaction that happens that requires an index change, we actually pile them in a queue. And we take that whole queue and ask Lucene to do that upgrade in a single batch, okay? And what is slow from a Lucene point of view is not the fact that you do your work in memory, is to do an I.O. to actually flush that information to disk and then come back. So if you were doing an I.O. for every single transaction and every list of changes you wanted to apply, that would be slow, right? If you had too many transactions, that transaction would have to wait for all the other transactions to happen. What we do is we take the queue of all the transactions and we apply them in one batch. While we are doing this one single I.O., the queue is probably filling up, but that's okay. Once we're back from a Lucene point of view, we take that queue again and then we apply it. So from a transaction point of view, you come, you say, I want to index this stuff, and the most you have to wait is essentially one I.O. cycle. So it's not as fast as NRT because there is this one I.O. cycle, but that's pretty much as you will have to wait. So that's a very reactive and efficient pattern. Another biggie is that we have support not only for Apache Lucene, but also for Elasticsearch. So the big advantage, remember, is that you're working at the object level, and every time you do a node change from a Hibernate point of view, the ORM, we actually apply the change to the index. So here you can keep your Elasticsearch index in sync with your database transparently thanks to Hibernate Search. So that's the benefit you have when working with Elasticsearch and Hibernate Search together. And of course, you can still use Kibana and all of that because these are regular indexes, Elasticsearch indexes that you can access to. Did I forget one? Yes, we try to be good citizens with the kind of framework you use. So we've got a whitefly fragment that integrates Hibernate Search and whitefly swarm. Same on the Spring Boot side, so you should be able to get started very quickly. So this is a bit of a synthetic example where I tried to cramp as much features as I could. So you see that it's a regular JPA entity. So you've got the @entity annotation and the @ID on the identification. And I've got properties. What I had to do is to add the @index annotation on the address and just by doing that, Hibernate Search will be notified by Hibernate ORM about changes on the address object, which means I'll be able to index the information of address. Then I need to decide which field do I want in my full text index. There is probably many fields I'm not interested about from a full text index point of view, but only some of them. Well, in this case, I've been pretty comprehensive. But that's why you use the @field annotation. Add sortable field is interesting. It's when you want to return the result on ordered by city. So by default, a full text index, the advantage of it is that it returns the most relevant result compared to the query you've done. Just like Google returns the most interesting website compared to the query you've done. That's what it is about. But if you want to not order by relevancy, but by cities, then you just enable the sortable field here. Facet, we will mention it in a minute, but you have to mark the fields you want to facet by. And spatial. So we can do actually geolocation-based queries. So in this case, I've got an address with a latitude and a longitude, so I mark them as latitude and longitude, and Hibernate Search will do a quad index for you, and you'll be able to query by latitude and longitude. At Index Embedded is how you actually do the denormalization I was talking about before. So again, it's declarative. So the second step, once you've done this annotation, every time you do an update to an object, the index is actually upgraded by Hibernate Search transparently for you. So that's good. Now it's time to write queries. To write queries, you can use the native Lucene queries or the native Elasticsearch queries, but you can also use our object level DSL. And in this case, what we do is we do a spatial restriction by the radius. So say 5 kilometers around this latitude and that longitude. And then I want to search for a very specific street. Actually not so specific because maybe my user didn't type it properly. So I want to be approximative. I want to be able to do approximative queries here. And those two are mandatory. Those two constraints are mandatory. And I'm adding a new one which is optional, which says, hey, I'm actually looking for a rent. And hey, it would be interesting for me, it would be better if the rent for the condo that I want to look for is actually at 2 floors high or above. Okay, so that's the restriction I've done here. And it's not a restriction per se because I've used the should property here. What's happening is I'm saying if it's above 2, then the relevancy will be higher. The score will be higher, so the result will be high before in my results list. So that's the interesting part about a full text search. Here, that's an optional step, but you can add facets. So for people familiar with Amazon or pretty much any retail website these days, you write a query, you've got the results, but you also on the left have some kind of refinement capabilities. You can say, hey, I'm looking for, I don't know, memories. And then you've got, okay, you can use the Samsung brand or that other brand or that other brand. So you can select the brands you're interested in and not the other one. Or maybe you want all of the articles with 4 stars and above and not all of them. So this is called faceting. You can express faceting here. So here I'm doing a faceting on city. And it's discrete in the sense that all of the cities that are within my result will be exposed on the facet on the left. And the second facet is actually a range facet, which means I don't want the list of all the floors. Or for example, I don't want the price, every single price point. I want ranges between $0 and $20 and then $20 and $100 and so on. So that's how you describe those ranges. So I'm describing my faceting, and then I can describe my actual query. I bundle everything together, and I run my query. And if you look at it, it's an actual Hibernate query. It returns manage object. So it's just another way to do a query in Hibernate. You return, hello, you return manage objects, which means if there is a lazy association, you can go and navigate to the lazy objects and so on and so on. This one is a recent feature that I quite like. So if we look back to my query here, what I have is 3 parameters. One is the radius, the second one is the street name, and the third one is the floor level. So I have asked my user about those information, probably in different fields. Okay? Or maybe I've inferred the radius because I know the person wants it within 1 kilometer of it. But very often in a search engine that you expose to a user, what you have is just one box, just Google, like one box where the user puts everything, and then you have to write the best query for that, just based on the terms it put into this entry, into this form. So here I've got war, a piece, provided by the user. And what I will decide is just, okay, I want to search War and Peace on this, that's a book in this case, on the title and the summary. I think the title is more important, so I will boost it to a higher level. So if those names are in the title, they will be higher in my list of results. So it's really a nice way to simplify a bit your work when you know that you have a single form. That's the simple, what's the name? Simple query string operator. Okay, Hibernate OGM is essentially Hibernate ORM, but for NoSQL databases. So we do JPA API. We use the JPA API. You write the object model the way you describe the object model in Hibernate, but we store the information into MongoDB, Infinispan, and a few others that I'll mention a bit later. It's interesting if you have a domain model and you want to use one of those non-relational database, that's really where the model shines. So we do some of the JPQL query, not all of these, but you can write the native query of the underlying system. So you can write a MongoQL query and whatnot. Yeah, I find it interesting. If you have a non-domain model-centric stuff that you want to put, that's not the best job. Just like if you don't have an object model and you want to persist information, don't use Hibernate ORM for that. But if you have a domain model and you want to use those, that's the best. The other stuff we try to do very hard is to make it the most natural mapping possible. So it looks like somebody really wanted to store that object structure, was doing it in a MongoDB native way. So we don't try to serialize as a blob. No, we use the nested document approach. Or in the case of MongoDB, which is a graph database, we use nodes and edges between nodes. So we try to use the most natural mapping, the one you would have written if you had known about Neo4j very well and knew about those kind of pattern and approaches. So we've got support for those. The last two are really kind of experimental, but the other above are stable. How do I get started with Hibernate OGM? Well, first of all, you need the dependency to Hibernate OGM and specifically which dialect you want, so Neo4j in this case. And then in your persistence.xml, you say, hey, I'm not using Hibernate ORM, I'm using Hibernate OGM. And then you select the provider, Neo4j, and then that's it. Start using the JPA API and you're good to go. Hibernate Validator. Who uses Hibernate Validator? Okay, that's the implementation of the bin validation spec. What you can do with it is describe constraints on your objects. So here I have a user which has an email, an age, and a first name, and I want to express the fact that this email is not just a string, it's an actual email. So I use annotations to express that very close to the actual type. And that's declarative, and then from there, everybody using the Hibernate Validator API validating that object will actually validate those properties transparently and report the list of errors. And the cool stuff is that we worked hard with the other the rest of the ecosystem so that the validation happens at key points. When you enter JAX-RS and JAX-RS takes this JSON object, creates a Java object, you can actually call bin validation and have it executed. When JSF populates from a form, creates an object, it actually looks at the constraints here and actually apply them. So you describe them once and they are applied at the web layer or the entry point layer, but also at the output layer, JPA. Right before pushing data into your database, we check that the data actually is correct from a constraint point of view. Another stuff you can do for CDI or Spring is to actually validate the parameters of your methods. So here I want the user to, first of all, be there, not be null, and also be valid, which means please validate those properties of that user object when I'm calling that method. Okay, so that's bin validation, or that's Hibernate Validator. What we've done recently is work essentially everything related to Java 8. So we have introduced repeatable annotation, which is part of Java 8. So I don't know if you're familiar with annotations, but you couldn't put the same annotation twice on a given property or methods. You had to create a container. So say email.list, and then you put the various emails with the various properties. Now you can put @email, that works. What would you want to put twice @email, by the way? That's because Hibernate Validator / bin validations lets you group constraints into subgroups. And you can say, I only want to validate that subgroup and not that other subgroup. So defining the constraint several times actually is a need. Date and time. Remember Java 8 date and time, new types. We've got support for those. And if you compile with the dash parameters property, when we do the method validation, instead of arg0, arg1, and so on, we actually use the parameter name, so the error report is quite a bit nicer. But the big feature of Hibernate Validator and the bin validation spec, which is about to be final like in a month or two, is support for collections. So you could support constraints on collection, have been able to do that for a while. So in this case, I put a size on the list of emails, so I can have a maximum of 10 emails. But what if I wanted to apply the constraints not on the collection itself, but what's inside the collection? Well, Java 8 introduced the ability to put the constraint here within the brackets, and they call it something I can never remember, but that's within the brackets. So here what I'm saying is that it's a list of email that should not be null. And bin validation will actually look at each entry in the list and make sure it's an email that is not null. It's not limited to collections or iterable. Optional is another type where it makes sense. And we actually have an extension point. So Google Guava has a few collections that are not actual subtypes of Java util collections. They can implement the same stuff and inject it into bin validation. So I think it's called a table. The table with like a row, column, and value actually can be supported in bin validation. This one is interesting. That's a programmatic way to declare the constraint. That's specific to Hibernate Validator. So you can use the annotation to declare the constraints, or if you're static, you can use XML to declare the constraints away from your objects. But the third way is to use the programmatic API, which is safer from a point of view than XML, closer to your code, so I find it interesting. And it also means that, say you've got several deployments of the same app, but it's slightly different between customers. They don't really have the same constraints. You can actually customize the constraints between the various customers. So you would ask the customer to express the constraints, like a YAML file or so whatever the input, and use that input to call the programmatic API to express the constraints. Hibernate Special. We're back into Hibernate ORM, by the way. So first of all, I've been talking about geospatial queries with Hibernate Search. Hibernate Special, what's the difference? So the first one, Hibernate Search, the special queries actually use the Lucene index to do the actual quad query and the geolocal queries. Hibernate Special is really the integration between Hibernate, the ORM, and the actual geospatial capabilities of the underlying relational database. So Oracle, PostGIS, which is the PostgreSQL plus the geospatial support, MySQL, and so on and so on. They all have one shape or another of spatial support. How do I do it? Well, first of all, I add the spatial module to my dependencies. I might need to use the specific dialect for the spatial support. And from there, this is an entity of mine, and I'm having an ID, and I've got a special type here, which is a point. So it's literally, I had latitude and longitude before in my previous example. Here, that's a point, which has probably a X and Y axis definition. And then I can use the object, persist it, and it will use an actual spatial index from, say, PostGIS in this case. So I'm using here the constructor for the point object. The point object is part of the JTS library, which is kind of a de facto standard for that in the Java universe. How do I write a query? That's a Hibernate query language query. So I'm looking for events, and I'm applying a within restriction from the location, and I'm applying, in this case, a polygon. So look for all of the Starbucks coffees within this polygon, right? Because I'm willing to get coffee, but only if it's as far as this, right? So that's how you do the query. And finally, and that's the last one, I've got no code to show here, but Hibernate Inverse is about auditing. So when you do a change to the database, the change happens and it's part of the transaction log, but you can only query the latest state of the database. Hibernate Inverse, when you do a change to the database, also keep track of what has changed. So it keeps your actual table model as is, but creates for the audited table an additional table per audited table, which will track the fact that this property has changed from A to B by that user at that time for that transaction. Okay? And what it means is that I'm able to do two kinds of query. One is to say, when was, for example, the date of that event changed from the 1st of July to the 5th of July? You can actually do those kind of query. When did that happen? When did somebody change that? The second type of query you can do is, let's pretend I'm 3 weeks in the past. Let's do a query of the state of the database 3 weeks in the past and look at what's going on and what was the state of the data. So that's useful for auditing purposes, trying to find what happened and what has changed and when it has changed. Of course, that's more expensive. Those additional tables, you need to do subselects and complex queries. But in practice, you'll probably use the real-time part of your application just like as is. There will be a little bit of an overhead on the right side. And you will only do those auditing queries when you really need them. So it's OK to have them a bit more expensive. So that's what Hibernate Inverse is about. Again, it's annotation-based. So you mark the entity as audit or audited. I kind of forgot. And then you describe the various ways. And I will stop here. First of all, first of all, migrate your whole Hibernate application to the new one. It would be better. Look at the features that I've described, especially from the non-Hibernate ORM project. Maybe you have those needs, and maybe you want to integrate them in your various applications. And give us feedback, give us advice. Hey, you really should have that features because I had that need, and so on and so on. So interact with us. We really love when customer or people, anybody comes to us and say, hey, I've got this great use case that you're not covering very well, and then we can interact with you. That being said, we've got plenty of time for lots of questions, so try and not be shy. And that's when nobody asks questions. That's a typical one. Yes?
Thank you for your presentation. I'm using Hibernate, but I'm also using Spring Data over Hibernate. So how do you think of Spring Data? Does it take away features from Hibernate, or does it features?
So the question is, I'm using Hibernate, but I'm also using Spring Data, which is kind of abstract. It's the Spring Data JPA that you're using, right?
Yes.
So the question is, how do we see it? Well, essentially, we see it as a fact of life. The people inside the Spring universe, they tend to want to use Spring Data, and frankly, it has a few. Well, I'm not a personal believer on those automagic method, method on interface that create queries. I don't find writing queries that much more difficult, but apparently people do. So that's okay. That's okay by me. It's like we don't see any problem with that. Just embrace it. The only problem we have is that when we break API, the Spring guys, they don't want to break stuff, so it might take a while for them to upgrade. But as far as Hibernate, pretty sure 5.1 and 5.2, the support is in there, so you can use them. So I would have to ask, Oliver and the Spring Data guys, but I don't think there is any. It's essentially delegation, so I don't see any significant performance difference between using Spring Data versus not using Spring Data. Another question? Yeah?
With Hibernate Search,
yeah?
it works very straightforward with a single machine, but when you have multiple machines connected to Hibernate Search, it becomes a nice plan to make two machines work together, because the local search is actually the file, in a local file system. So what's the association between multiple?
Okay, so Hibernate, so first of all, I disagree, but let's have a discussion. So the question is, well, the remark is Hibernate Search is a nightmare when you have more than one machine because Hibernate Search stores the index locally, and then if you have two machines, then you need to synchronize everything, and that's a mess. So we explicitly added features in Hibernate Search to be part of a cluster, and that Lucene never had and never will. What we have is the master-slaves kind of approach, even though you can select per index which one is the master. So you could really have in your architecture several masters to distribute the load, but it's a master-slaves approach where one master will receive every single indexing request from the system, apply them, for example, store the index in a network file shared directory, and then the slaves will copy on a regular basis the copy of the master, the index of the master, and we do a swap. So we've got one feature that does that, and to communicate between the changes request that the slave receives, we use JMS, for example, or JGroups as a way to communicate back to the master. That's one approach. I've got two more approaches for you. The second one is to use Infinispan as the way to store the index, because here Infinispan is a distributed grid that looks like local to everyone, but it's a distributed system. It's like a shared memory across machines. So you can store the index in there from Hibernate Search and have it shared across the machines. The third option is to say, well, use Elasticsearch, which is going to be your cluster, and Hibernate Search is just going to be the one asking for the change and doing the query and delegating that work to Elasticsearch instead of owning the index. We can dive a little bit afterwards if you want, but I think I've covered the overall things. Maybe one more question, or I don't know how much time we have left. But yeah? It's a great question. So the question is, if I don't update my data via my Hibernate application, but my DBA do some changes behind my back, like, those bastards. So we've got an API to manually ask for an index, so you might be able to know about that and then propagate that request. We've got an API that do a mass indexing of the whole database, so maybe every day you will decide to reindex everything, load the data as fast as you can, index it as fast as you can. That works. Usually we put MySQL down to its knees, so it's not going to be the indexing part that's going to be slow. And something we're working on is called the project Debezium.io. It's called Change Data Capture. It listens to a database changes from a transaction log point of view and create change events and put them in a queue. We hope to have an integration between Hibernate Search and that. So we could listen to every database change event, even if they are not coming from Hibernate, know about them and trigger the index. That's a little bit in the future, but you see the various pieces and we're trying to connect them. So I'm seeing maybe one last question because I'm seeing other people coming and probably the end of the session. Question? 3, 2, 1. Well, thank you for staying there. Thank you.